John Savio, welcome. It's great to talk to you. Thanks for your time today. What are some of the challenges that you're seeing agencies dealing with as they're either trying to transition into a DevSecOps environment or operate inside one as they're developing software, John?
Well, Francis, thanks for having me. Great to speak with you, sir. One of the biggest challenges I see federal agencies facing in the DevSecOps era is that they're really still, in many ways, developing to a waterfall methodology and delivering large chunks of capabilities at milestones, which can introduce a tremendous amount of risk in terms of mission success. That's what I've seen.
What are agencies doing that they think is agile that's actually waterfall? Like, what's the difference that they're missing in your view, John?
If you look at software testing, for example, NIST 853, for example, and the EO 14028 mandates the use now of various types of testing techniques: static analysis, dynamic analysis, software composition analysis, the production of a software bill of material, and even malformed input testing, or otherwise known as fuzzing. What I find is that many of the tests are done toward the end of a milestone, right? Rather than being done as the code is developed. And ideally, many of these tests can actually be executed in the authoring environment of a developer, such as an integrated development environment. So if they're doing those tests in the context of development of the software, right, in the context of authoring the software, it's a lot easier for them to remediate any defects, remove vulnerabilities that are related to security or safety or quality issues. When they do it at the end of a life cycle, there are delivery pressures, and the code has long since been written, and the developer may be onto another program. So it may be hard to get that developer's attention, and they're no longer in the flow of the logic of what it was that they're developing, which means it's more expensive, more time consuming, and riskier to remediate. So that's kind of the biggest challenges. Moving the testing back from almost at a delivery milestone and getting that right back to the desktop when the software is being developed.
Is that a matter of changing methodology? Is that a matter of changing policy, changing culture, something tactical, something else that I missed altogether?
It's really, I think I think it's all three, right? I think forcing a continuous ATO policy would then necessitate the testing prior to even the commit of a feature, right, to a build. So if you have a policy of forcing a test on what we call a pull request or the request to submit a feature, that policy would then shift the testing earlier in the process and force a change in the culture. And I think when a developer does that, their life becomes a lot easier. And then there's a bit more adoption because it's easier to remediate defects in software that way. So it's kind of a policy kind of forces the culture. I would put it that way.
Is that a hard pull for an agency, or is that just something that they don't have a lot of experience doing? Or what's your sense of why that is difficult for folks to get their arms around?
I think it's primarily culture, and it goes back to the milestone-based waterfall mentality that so many of these agencies still have. Now, there's others that are quite innovative. It just really depends on the agency and their mission and, like I say, the culture. But getting away from waterfall is the biggest challenge, I think.
Is there a way to measure that, or does someone just know it when someone sees it?
So I think one of the best measures of success in what we call shifting left and detecting defects and remediating them in the DevOps context is the percentage of defects in software that are detected and remediated prior to unit testing or prior to submission for a pull request as a percentage of all defects discovered through all life cycle states of the software development process. Because the higher the percentage of defects that are detected early in the software development lifecycle as opposed to later, that is a great way of number one, measuring the ability to catch defects early, and number two, the efficiency of the development process. So, percentage of defects caught up front, and then the amount of time it takes to remediate that defect. Because the later in the software development cycle that the defect is detected, the greater the amount of time and risk associated with its remediation. In fact, the amount of time needed to remediate a defect increases exponentially with time through the life cycle, if that makes sense.
It does make sense, and I appreciate you spending time with me today, John. Thanks very much.
Thank you, Francis. Have a great day.